Vanakkam. In this video, we are going to solve problem number 3.37 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. The question is to solve problem number 3.8 using mesh analysis. Already this problem was solved using nodal analysis in 3.8. Now we are asked to solve the same problem using the same circuit but with different analysis, that is the mesh analysis. And here we are asked to find out V0, where V0 is the voltage across 4 ohm resistance. And in order to find out V0, what are all the methods or tools used? Here we are going to use mesh analysis, and here we have two number of loops. This is loop number 1 and this is loop number 2. And here we have two loop currents being employed. This is I1 and the loop current 2 is I2. And what are all the elements present here? We have the voltage sources as independent and dependent. The independent voltage source is 60 volts voltage source and the dependent one is 5 V0. And we have the resistors 6 ohm, 20 ohm, 4 ohms and 20 ohms. And what are all the laws applied or what are all the laws used here? We are going to use two laws. The first one is Kirchhoff's voltage law. KVL. It states that in a closed path, the algebraic sum of voltages is equal to 0. That is sigma V. Summation of V is equal to 0. In other words, we can say sigma voltage rises, that is equal to summation of this voltage drops. And the second law which is used is Ohm's law, that is V equal to IR, where V is voltage and I is the current and R is the resistance. And in this, we have one more details, that is V0 is equal to minus 4I1, and this is taken as equation number 1. Actually, how do we get this minus 4I1? So V0 is the voltage across this 4 ohm resistor through which this I1 current is flowing. And for this V0, in the problem itself, the polarity is given as plus and here it is minus. But the I1 current is taken to be flowing in the clockwise direction. So it is flowing upwards through this 4 ohm resistor. This entering point is here, it is plus for this I1 and here it is minus. So the relationship between this V0 and the I1 is opposite. So we can write this as V0 is equal to minus 4I1. Now we are going to apply KVL for writing this voltage equation. So these voltage equations are required to find the loop currents. And first we consider this loop 1. And for this we can write the voltage equation. And we start from this point as current I1 is flowing in this direction. And it is flowing through this 4 ohm resistance. So it can be taken as minus V0. And then this current takes this path through this 6 ohm resistance from plus to minus. So it is plus 6I1. And here is where we are applying this Ohm's law. This is a voltage equation. So in each and every element we have to write terms of voltage only. Here it is already available in voltage. But here we know only this resistance. So we have to multiply this resistance with the current which is flowing through that 6 ohm resistance in order to get the voltage. 6 into that I gives you the voltage. And then the current flows through this. Here we have the 60 volt voltage source, independent voltage source. So we can mark it as such, 60 plus 60. Then here we have this 20 ohm resistance through which the current is flowing. So we can take this as plus 20 I1. At the same time, the I2 current is flowing in the opposite direction. So it can be marked as minus 20 I2. Then there is no element present. This particular loop comes to an end here. So that is equal to 0. Now we can add these two I1s together in order to get this equation rewritten as minus V0 plus this 6 plus 20 I1, that gives you 26 I1 plus minus this 20 I2, and we are bringing this 60 volts to this right hand side so that it becomes minus 60. Now we are taking this as equation number 2. Already we know that V0 is equal to minus 4I1 from equation number 1. Now we are going to substitute this equation number 1 in equation number 2, so that we can rewrite this V0 as plus 4I1, because already you have this minus sign. Here also again minus sign. So minus of minus, we get this as plus 4I1. Then this 26I1 minus 20I2, that is equal to minus 60. So adding this plus 4I1 plus 26I1, we get this as 30I1 minus 20I2, that is equal to minus 60. So dividing this by 10, we get this as 3I1 minus 2I2, that is equal to minus 6. This is our second equation. Now we are going to apply this KVL to loop 2. We assume that the current starts flowing from this point. So it is flowing through this 20 ohm resistance. So entering point is plus and this is minus. So that we get this as 20I2. The current flows through this path in which we have this dependent voltage source. Here the entering point is plus. So we can write this as plus 5V0. Then it is flowing through this particular path where no element is sent, so that we need not write anything there. This current is flowing through this 20 ohm resistor, so entering point will be taken as plus. Okay, so we can write this as plus 20I2. At the same time, this I1 current is flowing in the opposite direction, so it can be taken as minus 20I1. Then this I2 current is flowing through this 60. Then we have the 60 volts voltage source, but here this entering point is minus, so it is marked as minus 60. Here it ends at this point. It can be written as 0, that is equal to 0. So by rearranging them, we get this as 40I2 plus 5V0 minus 20I1 minus 60, that is equal to 0. And we are bringing this 60 to the right hand side. Once again we rearrange the terms in the proper order, that is I1, I2, V0, like that. So it is minus 20I1 plus 40I2 plus 5V0, that is equal to 60. This is our third equation. And already we know that this V0 is equal to minus 4I1 from equation 1. Now we substitute this equation number 1 in equation number 3, so that we can rewrite this as minus 20I1 plus 40I2 plus 5 into minus 4I1, where we have done this substitution, right? That is equal to 60. So this is minus 20I1 plus 40I2 minus 20I1, that is equal to 60. Multiplying these two, we get this as minus 20. 40I1 minus 40I1 plus 40I2, that is equal to 60. Dividing this by 20, we get this as minus 2I1 plus 2I2, that is equal to 3. This is our fourth equation. Now we'll get these two equations, that is second equation and fourth equation, in order to solve the simultaneous equations. So to solve them, we can add the second and the fourth equation. So this 2I2 is get cancelled from both the equation, because one is minus, another one is plus. So here while we are adding this I1 together, we get this as plus I1, that is equal to minus 3 amps. So in the question we are asked to find out only V0, isn't it? So that we bring this equation number 1. So substituting this I1 value, that is minus 3 amps, in equation number 1, we get this as minus 4 into minus 3. Okay, so that is equal to plus 12 volts. So this is our required answer. Hope you have understood. Thank you.